as like conceptual practice here, it says sketch out a graph that represents the relationship between energy and frequency. So let's just put let's just put energy over here and frequency which has the units of inverse seconds or hertz, and energy has a value of joules. Well, if I look down here, I see that as energy is going up, what's happening to the frequency? Well, if we know that as energy goes up, the wavelength goes down, then that must mean that energy and frequency are directly related, because we know that wavelength and frequency are inversely related. Okay, and then it says draw a wave with a large wavelength and one with a small frequency. And then we want something with a big frequency and a small wavelength. Okay, it says use the diagram below to draw an electron going from n equals 5. So we got 1, 2, 3, 4, 5, 6. So we're going from 5 right here to 2. And when it does that, it's going to emit a wavelength. And then let's skip 4 for right now. And it says use the diagram below to draw an electron going from 3 to 2. 3 to 2. That's going to emit a wavelength too. So this one has less energy. So from 3 to 2 is less energy than 5 to 2. Has more energy. And that's just because it's more energy levels, right? So let's go back up here. Less energy was red, and more energy was at the blue or violet, right? So less energy, more energy. So we could guess that less energy meant that we were at the red end of the spectrum. So this might be red, whereas this one might be blue. So if we were to compare the wavelengths on these two, let's just draw this, we would say that the squiggle, since this one has more energy, that means that this one has more energy. That means that its squiggle, let's go back up. If I check this, the wavelength for more energy was smaller. Wavelength for more energy was smaller. Whereas the blue one, back up here, was much longer. So, again, less energy here, and more energy here. Hope that helps.